Welcome to my video on 13-8 reciprocal trig functions. So we are skipping 13-6 and 13-7 temporarily. We are going to return to it after this section. So I'm just rearranging some stuff. So the aim of today is going to be to evaluate reciprocal trig functions. So we are going to be using skills that we learned in 13-2 and 13-3. But this time applying it to a few new trig ratios. So first we have to recap what the primary trig ratios are. So when I talk about primary trig ratios, I'm talking about the phrase SOHCAHTOA, right? These relationships between sine, cosine, and tangent. So sine is the relationship between opposite over hypotenuse on a triangle, right? Labeled with a theta. This would be my opposite side. This would be my adjacent side because it's attached. And the side opposite my right angle is always called my hypotenuse, okay? So sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And my tangent is my opposite over adjacent. So you do need to know those in order to understand what we call the reciprocal trig functions. So hopefully you know what the word reciprocal means, right? If I have a fraction, let's say 3/4, the reciprocal of it is 4/3 because it is flipped, okay? So the reciprocal trig functions that we're going to look at today are going to be these primary trig ratios flipped. So let's take a look. So there are three new functions we're going to be looking at. And they are going to be closely associated with one of our primaries. So the reciprocal trig function that is closely related to our sine function is called our cosecant. The reciprocal trig function that's related to our cosine function is secant. And the reciprocal trig function that's related to the tangent is the cotangent. Now, obviously, tangent and cotangent make sense. They sound alike. But what is often confused is sine and cosecant, cosine and secant, because we always want to put S with S and C with C. So what you need to remember about these is that for any pair of reciprocal trig function, right, sine, you need one S and you need one C. So sine has to go with a C word. Cosine has to go with an S word. Okay, so one C, one S. So if sine is opposite over hypotenuse, what do you think the reciprocal trig function is going to be? Well, it's going to be flipping over that fraction. So my hypotenuse over my opposite. If cosine is adjacent over hypotenuse, what do you think its reciprocal trig function secant is going to be? Well, we're going to flip that fraction. Put hypotenuse over adjacent. And if my tangent is opposite over adjacent, my reciprocal of that is going to be adjacent over opposite. Okay, so that is one way of looking at these reciprocal trig functions, is to relate them back to the triangle and the correct sides. Okay, so as long as you know which reciprocal function is related to which original primary function, these calculations shouldn't be too challenging. So let's do a few examples. Okay, so what have we looked at? Well, we definitely calculated the first half of this chart, right? We did sine, cosine, and tangent for all of my special angles, my 30, my 60, and my 45. We're going to do the same thing now with our reciprocal trig functions, okay? So my cosecant, remember, is the reciprocal of sine. So that means my hypotenuse over my opposite. Secant is related to my cosine, which is my hypotenuse over adjacent. And my cotangent is related to my tangent, so that's not opposite over adjacent, it's adjacent over opposite. So if we still go back to these original triangles, we should be able to calculate any of these values. So cosecant of 30. First, we want in our numerator our hypotenuse. 2. Over my opposite. Remember, the opposite is the one that's across from it. Okay, so my cosecant of 30 is going to be equal to 2. Notice that is the reciprocal of the 1/2 that you see in the sine column. Cosecant of 45. Okay, so we want my hypotenuse, which is radical 2, over my opposite, which is 1. So we simplify that and we get a radical 2. So now, if we look at the sine of 45, it doesn't look like an exact reciprocal. And that's because this one right here is rationalized. Remember, when you have a radical in your denominator, you need to rationalize it so that there's no longer a radical. So they won't look like they're direct reciprocals, but they are if we go back to the original calculations. Okay? What about 60 degrees? So we go back to this triangle. Looking at 60, we want our hypotenuse, which is still 2, over our opposite, which is radical 3. We have a radical in our denominator, so we must rationalize. So I'm going to just take this out of here. This is equal to 2 radical 3 over 3. Now, if we look back at the original, before we rationalize, it is a reciprocal of what we see in that chart. So that's what I mean about when it's rationalized. It may not look like it's a reciprocal, but it definitely is. Okay, so I want you to pause the video and try the other 2 columns. When you're done, take a look back and see if you got the work right. Okay, so secant is hypotenuse over adjacent for 30. We already know the hypotenuse is 2. What is my adjacent? Radical 3. Well, we already rationalized this, and we know that this is going to be equal to 2 radical 3 over 3. Right? The work for that is down here. Hypotenuse over adjacent of 45. So hypotenuse is radical 2 over adjacent is 1. This reduces down to a radical 2. And for my 60-degree angle, we want my hypotenuse, which again is 2, over my adjacent, which in this case is 1. And we get the answer 2. Again, notice, other than the rationalized ones, we do see some reciprocals in our original calculations. Cotangent, adjacent over opposite. So of 30 degrees, my adjacent is a radical 3. My opposite is 1, giving us just radical 3 as our answer. 45, adjacent is 1, opposite is 1. We get a final answer of 1. And 60, adjacent is 1, over opposite is radical 3. We must rationalize that, so I'm going to just bring this down here. Radical 3 over radical 3. We get a radical 3 over 3 as our final answer. Okay? So every calculation that we've done with sine, cosine, and tangent can be done with cosecant, secant, and cotangent. Which means that we're going to be doing all of the same calculations we did in 13-2 and 13-3, but with these 3 trig functions. So now another way we need to think about reciprocals, okay, is that it is often written as 1 over its reciprocal value. So for instance, if I want the reciprocal of 3/4, that is equal to 1 over 3/4. Well, how do we get the 4/3? Well, if you remember, keep the numerator, change the multiplication, and flip your denominator. That's where we get the 4/3 from. So we tend to skip this middle step and usually go directly to the last step. But it is not useful in all cases, okay? So this is an identity. And again, this shows you the actual relationship between my sine value and my cosine value, cosecant value. So if I wanted to calculate a cosecant, what I would do is I would put 1 over sine. If I wanted to calculate a secant, I would do 1 over cosine. If I wanted to do a cotangent, I would do 1 over tangent value. All right, so this is how you're going to plug it into your calculator. There is no cosecant, secant, or cotangent buttons. Okay, you must use the primary trig functions to calculate the reciprocal trig functions. So what do I mean by that? Well, we want to calculate, right here, cotangent of 13 radians. Okay, cotangent is the reciprocal trig function of tangent. So if I wanted to find a numerical value for this, I could plug into my calculator 1 over tangent of the same value. Okay, now when you plug that into your calculator, you should get 2.15972 ... Okay, so the value of cotangent of 13 is equal to that value. Obviously, that's not an exact value, but it is an approximate value. All right, so if you wanted to do your calculator, we're going to be using these identities. So cosecant, CSC, of 6.5 radians. Cosecant is related to sine. Okay, so if I want to find the cosecant of 6.5, what I can do in my calculator is type in 1 over sine of the same value. Now remember, all of these are in radians, so you want to make sure the mode of your calculator is in radians. If these were degrees, you would want to plug in, make sure it's in degree mode. Okay. So when I plug this into my calculator, it should get 4.64856 ... Okay. Now what about the last one? Secant of 3 pi over 2. Well, secant is related to cosine. So if I wanted to plug this in my calculator, again, pi means that it's going to be in radians, I would type in 1 over cosine of 3 pi over 2. Okay, now when you type that into your calculator, you should see something interesting, a big error. Okay, this is undefined. Okay, your calculator will give you an error when something is undefined or there is no value for it. Okay, so now let's explore why this is undefined. Okay, because that's going to help us figure out how to do the next section of work. So if I'm thinking about the angle 3 pi over 2, I can convert this and understand that this is the angle 270 degrees. Okay, and I only do that so that I can show you my graph. Okay, the angle 270 degrees looks something like this. Now, if you remember, right, anytime I want to find a trig function on that works out to be a quadrant angle, I want to look at my unit circle, okay? Because we don't have any relationships for our quadrant angles. So we look at where it intersects our unit circle. Remember, unit circle has a radius of 1. So this is going to intersect my unit circle at the point 0, comma, -1. Okay, now if you remember one step further, on the unit circle, my x value is equal to my cosine, my y value is equal to my sine. Okay, so although I may not know what this is, if I wanted to calculate 1 over cosine 3 pi over 2, I can replace my denominator with the x value that I see here, right? Because that's cosine of 270 or cosine of 3 pi over 2. And that's a 0, okay? So when we have these reciprocal trig functions, we have to be wary of having 0 in our denominators because that gives me the undefined values that we're going to have to watch out for, okay? So if you ever get an error on your work, please know